Okay, hi everyone. This is going to be part 3 of the self-study physics series. So at this point, we've covered most of what you should do in high school. So algebra, trig, a little bit of probability, and sort of introductory classical mechanics and electromagnetism without too much mathematical background. So at this point, I would say you're pretty much ready for university level mathematics and physics. And the most important thing to start with is to get yourself a nice, big, fat calculus book, good old 1,000 page textbook. This is the one by Minton and Smith. Um, I don't think this textbook is commonly used, but it's a perfectly fine one. I think the one by Stewart is by far the most commonly used one, but a big fat calculus textbook because you're going to be doing a lot of calculus in physics. It's extremely important. So in terms of what chapters you might want to cover in a book like this, um, you absolutely need to do chapters on limits. I would say differentiation, um, and you need to know things like the product rule, the chain rule, the quotient rule, etc. And you need to know derivatives of trigonometric functions too, and exponential functions and so on. Integration techniques are also very important. Um, you might want to take a look at first order differential equations at this point. It's probably not going to be super helpful for the physics you're doing immediately, but it will become important. So maybe you can look at ordinary differential equations. Um, Eventually, you'll pretty much need to know almost everything in a textbook like this once you get to more advanced stuff. But yeah, certainly the stuff I've mentioned so far is important, and then you can also just continue working through a book like this or Stewart. And with calculus, it's really, really important to spend a long time on this and really master it. You want to make sure you really, really understand it because calculus is foundational to, well, it's used in a lot of other areas of mathematics and it's foundational to physics. Calculus you're going to use everywhere in physics. So put a lot of effort into calculus now and you won't regret it. It'll help you later. Then, in terms of other prerequisite maths, I would say you should get yourself an introductory, if it focuses, an introductory linear algebra book. Um, this is one by Coleman and Hill. Any good linear algebra primer will do. But at this point, you especially want to focus on vectors. So you're going to want to learn about how to normalize a vector, how to add and subtract vectors, what's a dot product, what's a cross product. I think those are the most important things. That shouldn't take you very long. And then eventually you'll want to get into linear equations and matrices and those types of things. But I think for now, just focus on the vectors. Um, and then you can get to the more advanced topics a little bit later. Because that vector stuff and calculus is what you're going to need to do your sort of first year university level physics. So for the purposes of that, you want to get yourself a nice general introductory textbook. So, for example, here I have Giancoli's Physics. And as we did previously, you really want to focus on the classical mechanics and electromagnetism parts of a book like this. Another commonly used textbook is University Physics by Young and Freeman. That's actually what I used in my first year of physics, but I thought I'd give a shout out to Giancoli too. Um, so what we're kind of doing now in the physics journey is we're going to keep doing electromagnetism and classical mechanics mainly, but we're going to add a little bit more complexity because we're going to start using calculus and we're going to start looking at some slightly harder problems. Um, So that's, quite a nice textbook to go through. And then you'll notice if you page to the table of contents in a book like this, you'll notice that it has a lot of chapters that are not electromagnetism or classical mechanics related. And you might have fun looking at those chapters. They often provide a brief sort of introduction to certain things. Like, for example, we have some special relativity here. There's a little bit on quantum mechanics, which might be a little bit advanced right now, but I'm not sure how much mathematical depth it goes into. Eventually we will get to quantum mechanics, but I think this video is already sort of getting up to time, so that may be for another video. But you'll also notice here there are chapters on thermodynamics, and there are also chapters on some other topics in physics, like nuclear, elementary particles, and astrophysics and cosmology. There's also some stuff on radioactivity and nuclear energy. And the reason I bring up these chapters is that they might just provide you a nice general overview of some topics in these sort of subject areas. So you might be like, "Ooh, well, I've heard about radioactivity and I want to know more about it." Then you can sort of just page to that chapter and read through it. I wouldn't necessarily work through all of these chapters. I don't think it's necessary, but it'll provide you with maybe an interesting overview of some of these chapters and then of all of these areas. And then you can look for specialist textbooks in those areas. Get yourself an actual nuclear physics textbook and look it up, or get yourself an actual, general relativity textbook and look it up, or whatever topic it is. So they might be interesting to you to as a sort of primer of some of these areas that you can kind of look into as something that may be interesting. So yeah, so this is where physics starts to get really interesting, but we're kind of still laying the foundation for subsequent university study, which I think I'm going to discuss in the next video. Okay, thank you for watching.